Hi, my name is Pankaj Zairu and I am making this program to make it calculate electric field due to more than 1 points. Alright, so I'm going to suppose a graph where I'm going to draw the axis that's given by this line, this line which is y-axis, sorry, uh, yeah, this line right there, which is y-axis, another line which I would draw is going to be for the x-axis, and this and another line that's gonna be for the z-axis. So I'm gonna write it down. This is x, this is y, and this is z, just for representation that I'm drawing everything in three-dimensional space. Alright, so I'm gonna suppose 2-point charges in this space. Let it be this charge, that's gonna be A, and another charge right here, that's gonna be B, and my aim is to find the charge at a point, let's say P. So what I'm gonna do is I'm gonna make a vector out of it. So the vector goes like this. There you go, the vector for A, where point charge A is located, the vector B, where point charge B is located, and my aim is to find the vector my aim is to find the charge on P due to vector A and due to vector B, and I'm gonna draw a line between A and P, another line between P and B. Alright, so but my target would be to find the charge magnetic field at P. So that's my point. Alright, let me suppose the distance from origin to the charge A be RA, and the distance from origin to charge B be RB, and this distance from O to P be R. So basically I'm gonna find the electric field at charge P due to charge A. So first I'm gonna find electric field on P due to charge A. That's gonna be EA equals to 1 over 4 pi epsilon naught, the charge on A, let's say for me that's QA, times now I'm gonna find this vector AP. If I apply the rule of vectors, then this vector AP is gonna be R minus RA. Since this R is the bigger vector and this R is a small vector, and I'm going from O to P this direction, so and the vector notation for this is right there, so it's gonna be R minus R. In the same way, this vector this distance from P to B that's gonna be BP is gonna be R minus RB, R minus RB. Let me draw it properly, R minus RB. So now the 1 over 4 pi epsilon QA times R minus QA over R minus RA whole squared. I'm gonna multiply it with the unit vector so that it gives me both the direction and magnitude of electric field on P due to charge A. So electric field, so I'm gonna do that. So that's gonna be R minus RA over the magnitude of R minus RA, which is the formula for the unit vector, which is the formula to calculate the unit vector. So this basically gives me QA over QA times R minus RA over 4 pi epsilon naught times this modulus of R minus RA whole cubed. So that's it, and in the same way I can find it for EV. I'm not gonna explain the whole thing, I'm just gonna write it down. The final expression, that would be EV equals to QB times R minus RB whole bracket over 4 pi epsilon naught R minus RB cubed. That's not proper. There you go, cube. And basically the charge on P due to A and B is gonna be the the electric field on P due to A and B is gonna be simply the addition of electric field due to A and due to B. That's gonna be E total equals to EA plus EB so that's my formula for today. So basically I'm gonna plug these values in there, and then I'm gonna make a program in vpython that explains how that writes the code so that when I plug in the values, the program is gonna give me calculate to me the electric field on that point due to two different charges. Alright, there is my program right here. So I did from future import division print function. So I imported it from so that it works in vpython, and from there I imported import math. I imported this software, this program, which helps me is do my calculations. So the first step I'm gonna do is introduce my constants, declare my constants. So this code right here, OOFPEG, stands for 1 over 4 pi epsilon 0 equals to 9 into 10 to the 9. Again, QA is, I'm supposing any arbitrary charge, 3 into 10 to the minus 9 coulombs, QB 4 into 10 to the minus 9 coulombs. Similarly, I'm supposing a vector to be 3, 1, 7 in the space. Similarly, another vector RB minus 1, 6, minus 7. Do you remember these RA, Q and QB represent this A, this B, and QP. So this is basically the QA, and this part is Q. This charge is QB. It looks proper. Okay, let me go to the code, and then I choose a random arbitrary point vector 2 at 4, which is basically gonna be this P. So that's the coordinates of that point in the space. And I wrote my formula down: E field equal to 1 over 4 pi epsilon 0 times qa times r minus ra times 1 over, and this thing right there, math dot power, I imported it from this software that calculates, that gives me the power function, I mean index function, or exponential function. And I wrote my formula: 1 over magnitude of r minus ra powered 3 plus, in the same way, the same thing. And then I print, and I did print magnetic field. Then let's say what the run gives. Run module 5 f5. There we go. So this thing right there, 0.6772 Tesla, it's gonna be the magnetic field for this calculation. Thank you, Dr. Rhett for making us do this video. That helps a lot in understanding the material. And thanks for watching it. Thank you.